Good evening. You're very welcome to the fourth webinar in this series from myself and my colleagues here in Teagasc, LAgriculture, Donegal. My name is Cian Condon. I'm a dry stock advisor based in Manorhamilton, County Leitrim, and I'll be your host this evening. And tonight our focus moves on to the environment. We're all aware of the pressures farmers are facing to reduce emissions and to protect the environment. And this whole area is likely to be central to the new CAP agreement over the next couple of years. So tonight, my colleagues Eamonn and Avery from the Ballymote office will be covering greenhouse gases, and Shaun Roarty from the Ballybofey office will be covering biodiversity. And both Eamonn and Shaun will be speaking for about 20 minutes, and we'll allow some time at the end then for your questions. Now, since we can't meet our usual meetings, with farm walks or seminars, we're hoping to keep things interactive tonight. And at the bottom of your screen, you'll see a question and answer function. And you can send your questions to our panel right throughout this evening's session, and I'll put them to the panel then at the end. So without any further ado, I would like to ask Eamonn to share his screen, please, and we will begin.
Good afternoon or good evening, everyone. My name is Eamonn Avery. I'm here this evening to talk to you about greenhouse gases and emissions from Irish farming. The questions I want to try and investigate this evening are: what are the gases? Where do they come from? Why are they such a big deal? How much do we produce? And what we can do to reduce them? And then maybe more importantly, by the end of the talk, what can you do as individual farmers to help to reduce them? Just what are greenhouse gases? And just to take it back to its very basic level, a greenhouse gas is a gas that absorbs and emits radiant energy within a thermal infrared range. Sunlight passes through the atmosphere and warms the earth. Infrared radiation is given off then by the earth and out through the atmosphere again into outer space. Without greenhouse gases, there would be no life on earth. So greenhouse gases are essential to allow life on earth. But some infrared radiation is trapped by the gases in the air, including CO2, to keep the earth warm enough to sustain life. Indeed, the ambient temperature of the earth, taking the whole surface into account, is about 15 degrees Celsius. And that's enough as an average to keep and sustain life. The predominant greenhouse gases are water vapor, carbon dioxide, methane, nitrous oxide, and ozone. What has happened in over the passage of time, especially since the Industrial Revolution, is that the proportions of these gases have changed. Because of the burning of carbon fuels, land clearance, and competition for natural resources on Earth, the amount of greenhouse gases have increased in the atmosphere. Therefore, the reaction with the infrared leaving the Earth and hitting against the molecules of glass has caused the Earth to warm up somewhat. This is given to the alarm over greenhouse gas and global warming. Alongside that, and maybe put the pressure on that to happen, is that the population of the Earth has increased. Go back around the 1800, the population of the Earth was about 1 billion people. By 1950, this had increased to 2.5 billion people. And by 1987, it had doubled to 5 billion people. The current human population of the Earth is about 7.2 million people. It's predicted that will increase to 9 million or billion people by 2050. And just as an aside then, 1/8 of the human population is on the breadline, possibly starving. So as farmers and agriculturalists, there's a problem there to solve to feed the people. and there's also a problem to sustain the earth and sustain the habitat that we live in. So my next topic of discussion will be really what's agriculture's contribution to this, and where does Ireland stand? So if I look at if you all look at the graph on the right, with the map of Ireland in the middle, agriculture's contribution to greenhouse gas emissions is about 33%. Energy then in Ireland produces about 20% of the greenhouse gases, transport another 20%, and residential from people's houses and homes another 10%. So those four items produce about 85% of the greenhouse gases produced in Ireland. On a global scale, agriculture causes about 10% of the greenhouse gases. But because Ireland is basically a rural economy and agriculture is so predominant in it, agriculture comes to the fore as the predominant producer of greenhouse gases. So we're producing 33% of the greenhouse gases and 98% of the ammonia emissions. 80% of the ammonia emissions are from dairy and beef, and the remainder from pigs and poultry. And ammonia, although it's not a greenhouse gas, is a concern to the environment. The following gases contribute the most to agricultural greenhouse gases. Nitrous oxide, methane, and carbon dioxide are the principal greenhouse gases, and ammonia, although it's not a greenhouse gas, is a poisonous gas as regards health and environmental issues. So the various activities on the farm that produce methane, produce greenhouse gases are through tilling the earth and preparing for crops. We're releasing carbon dioxide and nitrous oxide. Grazing animals then produce methane, ammonia, and nitrous oxide. By land spreading animal waste, then we're producing ammonia and nitrous oxide, and housed livestock then produce methane, ammonia, and nitrous oxide. So all in all, you can see where the contributions from agriculture are coming from. Greenhouse gases are measured in kilograms of carbon dioxide equivalents. If we take carbon dioxide having a 1 as a value, methane compared to carbon dioxide is 25 times more potent, and nitrous oxide 296 times more potent. So although carbon dioxide may be the predominant gas, it is not the because of its size, the bigger molecules in methane and nitrous oxide produce bigger portions atomic weight wise. 3 kilograms of nitrous oxide, for example, is equivalent to a ton of carbon dioxide. So the emission profile there, then 57% comes from enteric fermentation. That's fermentation in the rumen by cattle and sheep. 30% then comes from nitrous oxide emissions from managed soils. Manure management produces methane as well at 7%. Manure management also produces 3% nitrous oxide. There are also smaller proportions produced by indirect actions and limestone spreading. Ammonia in agriculture then. Ammonia is an air pollutant, and it's released into the atmosphere by land spreading animal manures, spreading urea, urination by cattle, and from stored sources by storing slurry in tanks, and especially open tanks. Ammonia's emission profile then is 34% of it comes from housing, 15% from managed storage, 12% from grazing, 7% from hard standing, 7% from fertilizer, and 26% from manure management. Greenhouse emissions have been steadily on the increase since 2011, right up to 2017. There are indications there in the press recently that there's been a slight drop between 2018 and 19, showing the first bit of progress we've been made in mitigating greenhouse gases. Ammonia emissions then have also been on a similar rise between 2011 and 2018. However, we had a target to achieve by 2020, which we haven't achieved, and we have a higher target than to reduce them by 2030, and we're starting on an uphill battle. Ammonia reacts with volatile organic compounds in the air and nitrous oxide and sulfur dioxide, forming particulate matter with a size of 2.5 microns, and it has multiple short-term and long-term health impacts. Short-term include irritation in the eyes, nose and throat, coughing, sneezing and shortness of breath. A prolonged exposure to particulate matter can cause permanent respiratory problems such as asthma, chronic bronchitis and heart disease. It's a huge health risk with high releases of ammonia into the atmosphere. So the challenges for the industry. The industry is expanding to meet global food demand. Greenhouse gases and ammonia emissions have increased since 2011. 33% of the greenhouse gases are coming from agriculture and 98% of the ammonia emissions. There's a climate action plan out there, and at a European level we have the farm to fork, and Shaun will expand on these in his presentation. The 2030 targets are to reduce emissions by 10%, and this is going to be a tall order. Delivering carbon sequestration then of 10% as well by 2030. Carbon sequestration is reducing carbon and taking it out of the system. Ammonia targets are a 1% reduction by 2020 to 2030 and 5% from 2030 onwards. There's increasing political pressure on agriculture to reduce the environmental impact. The European Green Deal and the Farm to Fork strategy outlines this, and there's an increasing emphasis on plant-based diets for people going forward. Agri-Food Strategy 2030 has ambitions, and again, it's all part of the green architecture, which Shaun will expand on. Planning permissions are being refused due to ammonia levels. Indeed, 55% of the population live in urban settings now, and it's anticipated into the future that up to 68% will. They're hoping to achieve carbon neutrality by 2050, so that all the carbon being released from the system is being absorbed back into the system and not adding to the greenhouse gas burden. So planning beyond 2030 then, and the European Green Deal, there's a whole raft of legislation about this. The Farm to Fork strategy towards the modernisation of the CAP, the transformation of agriculture in rural areas, zero pollution Europe, transition to a circular economy, sustainable transport, just to mention a few. So there's a complex green agenda there going forward. There's an increasing likelihood that with the Green Deal and Farm to Fork at European level and the programme for government at Irish level, that the ask of agriculture will be actually increased. Teagasc's roadmap then and mitigation pathways will be One, to reduce the agricultural methane and nitrous oxide through lowering emissions from animals, animal waste and fertilizer. Sequester carbon then through land use change and forestry. And 3, energy efficiency and biofuels and biofuel production to reduce the overall energy usage on farms to displace fossil fuel emissions. Teagasc is setting up signpost farms throughout the country, because there's all different farming situations around the country. No two areas in the country farm exactly the same way or have the exact same mix of enterprises, and there's different climate and weather conditions everywhere. So we're setting up signpost farms, and these farms will be used to demonstrate through taking on certain mitigation actions, how they can improve their impact on climate change. We would hear an awful lot in the press and in the Farmers Journal and through Teagasc about the marginal abatement cost curve. Abatement is another word for reduction. So the incremental reduction of cost, this idea. So in explaining this to myself, I made up this kind of little model, and I hope it might help people understand it. I look at the marginal cost curve it's a chart with an X and a Y axis. The Y axis extends beyond the crossbar there, which is the X axis. Along the Y axis or the upright, we're given cost per kilogram of CO2 equivalent. The amount of mitigation then gained from whatever measure is employed is represented along the x-axis, and that also is measured in kilograms or kilotons of CO2 equivalent. Each mitigation action then is represented by a box, and the boxes will be colored different colors to represent different gases. So, for example, green may indicate methane, and blue may indicate nitrous oxide. The wider the box, the more implication the mitigation action has, the more effect it has. And the higher the box, then the cost or the saving is indicated depending if it's above or below the crossbar or the X in the curve. So all the mitigation actions in a marginal abatement cost curve will have different shapes and sizes. If it's above the X-axis, there's a cost to adopting the mitigation action. If it's below, there's a saving by adopting the mitigation action. There's always a gain to the environment, though. So just to bring you on to what a real MACC curve looks like, we can see here that there's various measures taken up. Mitigation actions represented in the blue boxes mitigate against methane, and the green boxes mitigate against nitrous oxide. And so the various improvements that can be made will be things like beef live weight gain, extended grazing, animal health, fertilizer type, diet, low emission spreading. There's no silver bullet that does everything. You need to deliver on all to get close to the targeted reductions that are required to meet our 2030 objectives. One of the mitigation actions that can be employed on a farm would be to change your use of fertilizer, and it has been recognized that Protected urea can give a large mitigation and very good ammonia, very cancels ammonia. Urea emits large quantities of ammonia. That's conventional urea. If you replace urea with protected urea to reduce ammonia, there's a big gain. Replace CAN with protected urea, you reduce greenhouse gases. So it should be a no-brainer to switch fertilizer use from conventional urea to protected urea. In talking to some of the advisors in the region, they have told me that on demonstration farms, some of the farmers have switched to protected urea this year with no change and actually a marginal increase in some of the productivity in grass gained from the use of protected urea. There's no real cost difference either. Just a change in the way people think. Less than low emissions slurry spreading, and that would be using dribble bars or that kind of system to bring slurry into contact directly with the soil rather than releasing it off a splash plate and up into the air. Less is already being done by an awful lot of farmers, and indeed irrigation farmers have to employ this method of slurry spreading from the 1st of January, and some of them are already at it. It lowers the cost of the losses of ammonia, it lowers losses of nitrous oxide, and gives better retention of nitrogen in the soil. It's likely that chemical N limits will be reduced into the future, and there's a need to maximize the value of slurry nitrogen to replace it. Nitrogen use efficiency then is another mitigation action. So keeping more nitrogen in the system, less loss to air and less to water. Using CAN incorrectly, putting it out in wet weather, putting it out on land that isn't suitably limed, and using it indiscriminately can cause high losses to air and to water. So better grassland management, avoiding overall application. Sometimes in Teagasc we recommend that you will put out your first dressing of nitrogen in February, but there's no point putting out nitrogen in February unless the soil temperatures have attained 7 degrees. So it's a waste to put it out unless you've reached that temperature in soil. You get low growth enough until March. If the soil is saturated, it's not suitable to put out because there's losses to air or maybe water as well. So you have to match your application to the conditions. Maximize the use of nitrogen slurry by timing it, getting it out as early as you can in the growing season, and using a method such as the low emission slurry spreading to bring it into contact as quickly as possible with the ground and not waste it. And watching weather, using the weather to guide you in the application of slurry. Soil fertility is very important, getting the pH right and the P right. To get the optimum use out of nitrogen, you must adjust your pH to around 6.3 and have your P levels right. So soil sampling is a must to optimize the use of fertilizer. Clover inclusion in new swarts is also very important because it has the ability to fix atmospheric nitrogen, and this can be used during the season then by grass. Extended grazing is possible, maybe not on all categories of stock, but certainly on with lighter stock, it can be extended in the shoulders of the year to optimize, optimize grass and optimize applications. So it's all just good farming. the EBI, the Economic Breeding Index, it's a single figure profit index used by dairy farmers, and it gives it's kind of like the STAR system in the with beef and beef farming, used to improve fertility, so that farmers need fewer replacements and get higher pregnancy rates, to encourage early compact calving, greater proportions of grazed grass in their diet, rather than calving them all over the year. Higher milk solids yield per unit of grazed grass, because cows perform better on grazed pasture than they do indoors. And then selecting then for improved health reduces deaths and disease. However, if we use the efficiency to increase cow numbers or don't reduce the chemical nitrogen, then we may have an increase in total emissions. The ammonia marginal abatement cost curve is interesting in that if we adopt two particular measures, that's the low emission slurry spreading and the protected urea, we'll mitigate 80% of the ammonia. And remember that 98% of ammonia released into the atmosphere comes from agriculture. So by adopting these two measures, we can mitigate 80%, which is, nearly the whole lot of the ammonia released. So it's really a no-brainer. A lot of farmers are doing the low emission slurry spreading already, but this needs to be extended. And by replacing urea with protected urea, then it's really simple, especially when there's no change in cost or no change in it's really simple anyway. Lower crude protein at grass, then regulation, costs, savings, lower emissions, and better performance. So there's no need to be feeding high crude protein meal when cows are at grass, because they're already getting enough crude protein from their grazed pasture. Slurry amendments, they're additives that are added to slurry, work, but still work has to be done to identify best practice. In terms of carbon sequestration, then the forestry is capable of storing large pools of carbon, and despite valiant efforts, the uptake of forestry hasn't really been good. But however, if timber goes into construction that's from felled trees, it's going into storage and it's not being released. If it's burnt, it's released back into the atmosphere. So if timber goes into construction, it's a very long term way of storing carbon. Commercial conifers can store up to 10 to 12 tons of carbon per hectare per annum, and deciduous trees can store 4 to 5 tons per hectare per annum. The scope on most farms for more forestry and trees, and certainly the scope for additional hedgerows. Even though it's a small role, it's a significant role, and there's other benefits in terms of biodiversity. So to conclude, significant mitigation is possible by adopting some measures on every farm. All farmers need to do is take up the measures. Regulation is going to play a role, but don't leave it to the regulators. Be proactive in this area. Nothing is asked that's particularly difficult. Pick 3 things you'd like to change this year. Maybe low emission slurry spreading, the use of protected urea, raising the EBI or the MRI in the case of beef cattle in the breeding program, lime, soil testing and applying lime, inclusion of clover in your swarts. Suggest you examine these options and maybe try and adapt them going forward. Can we meet our targets? The ball is in your court. Thank you for your attention.
Thanks very much, Eamonn. If you want to stop sharing your screen there, thanks a million for that comprehensive presentation there. Just as I'm watching the time there, just to keep an eye on things and to keep things moving along, I'm going to ask Shaun to share his screen there. And just while he's doing that, don't forget that we have that question and answer function at the bottom of the page. So if you wish to ask any questions on Eamonn's presentation or on Shaun's, that's coming up now, feel free to type a question into that question and answer section, and we will get to it towards the end of our evening. Thanks very much. Thanks very much, Shaun, if you want to go ahead.
Okay. Good evening, everyone. You're all very welcome. Leading on from Eamonn's talk, I'm going to talk about biodiversity on farms, where we're at, where we're going, and what we can achieve in the interim between now and the new CAP. So just give an outline there on the presentation. I'm going to talk about the context and the agri-environmental policy. What is biodiversity, the importance of it, the ecosystem services that biodiversity provides, and the wider services, and also about the bioindicators. What's all the buzz about? And then that'll lead me on to the habitats on farmland, and that will include hedgerows, field margins, and that will lead me on then to water as a habitat. And in particular, I'll speak about the ASSAP program that myself and Eamonn are involved with. And then I'll just give some outline of ideas for ways to enhance biodiversity on your farm between now and the new CAP. And then just sum it up with a summary. So just to give a bit of context and review where we are in terms of glass and so on. We've learned in recent weeks that glass is going to be rolled over into 2021. And we also learned that there's going to be a new pilot scheme and associated pilot actions. And those actions and that scheme will form the basis, or the thinking is that they will form the basis for a new REPS 2 type scheme. And that will most likely come in now in 2023 at the earliest. So we've heard a lot about the EU Green Deal and the strategies that are in place in terms of the farm to fork, biodiversity strategy, and so on. And then also the green architecture. I'll just outline how the payments and so on are going to be structured in the new CAP going forward. So if we look at the ecosystem services there, I'll explain that later on, and also the role of agriculture, how it relates to wider society in terms of the public goods and the services that it provides. And then I'll also discuss some of the sustainable pillars of CAP in terms of economic function, environmental function, social, and innovation in terms of EIP projects that are currently in place. So if we look at the 9 CAP objectives, they range from, this is for the new CAP going forward, they range from ensuring that farmers have a fair income, increasing competitiveness in the farming industry, creating vibrant rural areas, and also supporting generation renewal in terms of farm succession and so on. But if you look at the right hand of the screen, you can see there that a third of those CAP objectives are going to be associated with agri-environmental objectives in terms of climate change, environmental care, and also our landscape and biodiversity in general. So if we look at the new green architecture that's been outlined and where we are, so at the current architecture that's there, so it's basically the structure of the CAP that's there at present. We look at the very bottom of the screen there, we can see that cross-compliance forms a large role for the mandatory measures that farmers must abide by in terms of our commitments to good farm practice and so on. And we also can see there that greening formed a significant part of our BPS payment up until now. And that's going to be replaced by a new terminology that I'll discuss on the right-hand side of the screen in a second. And then we can also see that there's an agri-environmental scheme there, which was voluntary for farmers, and that was formed under Pillar 2 in the current context. So that would have been EOS and GLAS, those type of schemes. So if we move to the right-hand side of the screen and look at the new architecture that's been proposed, the greening part of the payment of your BPS payment will now encompass a new enhanced conditionality, and that is still going to be mandatory for farmers. But what they're asking there is basically that you're going to be asked to carry out extra measures on your farm in order to draw down those payments. And just to point out that your BPS is going to be changed into new terminology, as was what the SPS, the previous income support scheme, is now going to be changed to the BIS payment. So it's going to be the basic income support for sustainability. And then you can also see at the very top there, on the new architecture, you have the eco schemes in Pillar 1, and you also have your schemes in Measure 2, your Pillar 2, in terms of your GLAS type payments. So there's going to be a new requirement there in Pillar 1 as well, in terms of eco schemes, and we don't know how they're going to be formed yet. But 30% of the cap budget for Pillar 2 is going to be ring fenced for agri-environmental measures, and 20% of your Pillar 1 payment is going to be ring fenced. So that leads me on to biodiversity on farms. And I asked the question, what is biodiversity? So it's all that biological diversity, or all those living things that exist on your farm. And they include all the wild flowers, plants, and animals, the flora, fauna, and fungi, and so on. And they're all viewed upon as bioindicators. So they're viewed, their populations on farms are used as an indication of how healthy those habitats that are on your farm, in terms of hedgerows, field margins, and so on. And they give a picture to the legislators and the policymakers whether a new type of scheme directed towards renewing or conserving that species is warranted, basically. So that's what bioindicators are. So habitats on the farms, typically there's hedgerows on farms, field margins adjacent to the hedgerows. We have water courses or waterways, whatever way you want to interpret it. We also have improved grassland, semi-natural grasslands, and we also have peatland and woodland habitats. And they all have a value. They all have a value in terms of economic value, and they also have a value in terms of environmental or a habitat value. So the importance of biodiversity, as we all know, it sustains life on Earth. We're dependent on it for food security. We're relying on it for medicinal and human health point of view. That well-being or good field factor when you go out for a walk through the countryside. From an aesthetic point of view, our green image, how we're viewed abroad in terms of our green image. We also have different values then in terms of intrinsic values and our spiritual values associated with our town lands and respective areas. And that's basically just belonging to an area and having pride in the area that you come from. And those are all intertwined with human history and cultural heritage. And as Eamonn quite rightly pointed out, the importance of biodiversity goes beyond its function in terms of wildlife value. It can also help buffer climate change. So ecosystem services, what does that terminology mean? We're hearing a lot about ecosystem services in the news in recent while. Those are the services that are provided by the habitats and so on, and the ecosystem in terms of a support function, in terms of supporting biodiversity, habitat creation, soil formation, and so on. And then also from a provision point of view, the food and the clean water that's been produced on our farms. And we're very good at selling that abroad, and we must continue to hold that carrot going forward in terms of our agri-environmental footprint. And then also in terms of our regulating function, storing carbon in our peatlands, and so on. And then new measures that are being looked on at the moment is flooding, the ability of uplands to control flooding in the lowland areas. And as we know, a lot of areas down south are getting badly hit with flooding, for example. And then as I previously mentioned, it has that cultural aspect as well, intertwined with your ecosystem services in terms of education, aesthetics, and so on. So the loss of biodiversity, what are the main drivers of biodiversity loss in Ireland? Well, intensive agriculture and forestry has been highlighted. Overfishing, invasive species, changes in land use. Changes in land use is habitat loss or degradation, basically. The loss of habitats, and those are closely associated with intensive agriculture, and indeed extensive agriculture also, in terms of a lot of the peatlands that have been lost in the Midlands, for example. So if we look at the bioindicators, as I mentioned, they are the indicators of a habitat quality. So what's all the buzz about at the minute? Well, I suppose you have heard about the All Ireland Pollinator Plan and the decline in bee species that we're experiencing in our lifetime. Now, a third of all bee species are actually in decline. We have about 98 species in total in Ireland, and those species are being looked at, and there's no doubt that they'll form some part of future schemes that will be implemented down the road, as well bird and your plant species as well. So, as I said, the bioindicators are being used to draw up the CAP, the future agri-environmental schemes. So I've put in results-based programs there at the bottom. There's been a lot of talk about results-based programs, and they could encompass coppicing a length of hedgerow on your farm, for example. We're very lucky here in the west of Ireland. We have we're blessed with the amount of habitats and biodiversity that we have, and it should be very easy for us to meet our objectives and the CAP going forward. But look, there will be challenges there for the more intensive producers. But we have the uplands program there, the uplands up in Inishowen, and we also have the pearl mussel up in Garton. So just mention then about local biodiversity. It's indigenous to our areas. It's unique. They have adapted over the millennia, and what I'm talking about there is the plants in particular, but also the animals that come and migrate here during the winter and the summer and so on. And I just put up the soil seed bank there as an illustration. The seeds that are produced in your hedge bank, for example, those seeds exist in that hedge bank, some of them up to 100 years, and they'll remain in that soil seed bank, and they'll sit there. They might be lost by predation, or they might be lost by natural failed germination and so on, but they'll sit there until successful germination allows them to flourish, basically. And that could simply be, in terms of a scheme going forward, it could be fencing off a particular stretch of a stream, for example, and then you'll see these wildflowers coming back into the areas. But the point I'm making is the seeds are there, they're in the soil, and they'll be allowed to flourish. So if we look at hedgerow importance, they act as wildlife corridors. That's what they are. They add to the landscape structure, that bocage structure that we have in Ireland, that patchwork or quilted landscape that we have. And as part of the CAP, they're looking at habitat connectivity in terms of future schemes. How can we link up isolated land parcels? How can we link up woodland with hedgerows and maybe a water course or so on? So that's going to form a significant part of how schemes are going to be drawn up, and they'll be drawn up. It could be drawn up at a local level to target certain species. So I've put up a box there on the invertebrates or the bugs, the little creepy crawlies that are associated with various trees, the flies and so on, and we can see there that our native tree species, the oaks, the willows, the birch, and the whitethorn, they support a significant amount of species these are just not numbers of insects as such, they're actually species. And you can see there that our non-natives don't support the same amount. So it's very important that when we are considering planting new hedgerow in the future, that we plant native species. So the benefits of hedgerows, we all take it for granted. And from an animal welfare point of view, the field boundaries that, they form enclosures for our land. They provide shelter and windbreak for our livestock. They provide biosecurity in terms of preventing pests and disease from moving between farms and so on. But then also from an aesthetic point of view, that green image that we're known for throughout the world, we must sustain that and maintain that going forward. And that's a part, we have that bocage landscape that's associated with north of France, UK, and ourselves, that patchwork of quilted fields. So in terms of the environment, then they act as highways for movement, nesting, feeding of small mammals and birds and so on. And they also act as a refuge. I mentioned the point there about the soil seed bank. Those plants, those rare threatened plants like cornflower and so on, they'll sit there in that field margin and they'll wait for their time to shine. I'll put it like that. And they're a refuge for our threatened pollinators also. So from a wider environmental point of view, then hedgerows are beneficial in improving water quality, infiltration, water retention, and also for providing a function in terms of preventing soil erosion. And as Eamonn mentioned, they have a role in carbon storage or sequestration, the take up of carbon. And there is a study being carried out in Johnstown Castle at the moment looking into the ability of hedgerows and absorbing carbon and so on in terms of biomass. So I have four different pictures there, and you can see there the question is which is best for biodiversity. If we just start at A, it goes without saying. There's very little internal hedgerow in that prairie, and the biodiversity value of that particular piece of land will be obviously low. And then when we move over to B, we have a short back, neat and sides type of hedgerow. It does provide a corridor function, but you're losing the flowers and the berries that those hedgerows will provide throughout the year. So ideally, we want to hit somewhere between C and D. C, you have your hedgerow. It's not that high, but it has that occasional trees, and they're flowering there for birds and so on. But then you have D, which is a mature hedgerow, and the point I'm making there between the two of them is if you have a mix of hedgerow, either in the case of C or D, you're providing that type of habitat, a mixture of a habitat where some species will favor open areas and some species will favor a more dense or closed canopy. So how do we manage the hedgerows that I have up? We have A there, it's a relict hedgerow. It serves a very good biodiversity function. The canopy is well developed, but we don't have that dense space for nesting birds and so on. So what we can do there is we can fence that off and prolong its life. In terms of B, we have a escaped hedgerow. It has missed management for a couple of years, but if we coppice that or lay that hedgerow, we can thicken that hedgerow up and it can become the hedgerow that we want. So C is the hedgerow that we want. It has an A-shaped profile. You can see it's wider at the base and it's leading getting narrower at the top. It has the saplings coming through there as well. It's not quite mature enough, but it's certainly getting there, and it has been kind of manicured, but it provides a higher biodiversity value. And then D, it provides very little biodiversity value, only as a corridor basically for the movement of small mammals, because it doesn't have the flowers and it won't produce the seeds and so on. So hedgerow hedgerows, and if I just give you a few top tips for managing your hedgerows going forward. Maintain hedgerows at least 1.5 meters high. They should be shaped to an A shape, dense at the bottom. And the point I'm making is untidy hedgerows aren't necessarily bad looking, or they're actually very good for wildlife. So a mixture of vegetation height or hedge growth is more beneficial than a completely tidy hedgerow. And that leaves flowers for the birds and bees and so on. And we should be leaving our occasional thorn trees as well. And if possible, we should be trimming our hedgerows on a 3-year rotation and avoiding cutting hedgerows between March and August inclusive. And we all know that one. So field margins then, they're structurally diverse. That's the area right adjacent to your field boundary, which may be your hedgerow or a stone wall. And they provide open areas for feeding, cover and refuge as well for plants and your small bird species that prefer open areas for feeding and so on. And they're going to feature as high diversity landscape features as part of the new schemes and the CAP. It has been highlighted in the Farm to Fork. So more than likely, they will form part of future schemes in terms of results-based initiatives. So then that brings me on to water, right? So water as a habitat, its importance. And as I mentioned, myself and Eamonn is part of the ASSAP program. And there's a river basin management plan there. The current river basin management plan runs up until the end of next year. That's required under the Water Framework Directive. And this plan sets out that all waters in Ireland must achieve good ecological status by 2027. So that is called the ASSAP program. And it stands for the Agricultural Sustainability Support and Advisory Program. So I look after Donegal and Eamonn looks after Sligo and Leitrim. So what is it? It's the principles of the program is based on the fact that approximately 50% of our waterways or rivers in the country are at inadequate status. And this program is basically sets out to try achieve good status by 2027. The current program runs up until the end of next year, and we're currently in review at the moment, and we'll know in the not too distant future how we fare. So the ASSAP program provides farm advice and support to farmers only. It's confidential between the farmer and the advisor, and it provides a service to all the farmers in the areas for action. The areas for action are selected by LAWPRO, which is a state body, and they have catchment assessment teams, scientists basically that go on out into the streams, carry out their assessments, and that forms the basis of their judgment then on the state of the habitat or the water quality in a particular area. And myself and Eamonn goes out then and we do follow-up visit with the farmers. So these are all the catchments that are located throughout the country. There's 12 in Donegal. The Finn catchment is the largest of all throughout the country. And there's a mix of pressures, and agriculture is one of the pressures that's been identified. So there's the PAs for Donegal up until next year, and there's going to be more selected in 2022. They have been identified, and that'll come on stream from 2022 onwards. So in terms of a catchment, what is a catchment? So a catchment can encompass a large area, as you can see there with the Finn. It's a very large area, or it could be a very small area, but it takes into account all the farms in a particular stretch of a stream. And that's what we're talking about when we're talking about catchment scale. So the pressures then, I mentioned agriculture is one, urban runoff is another problem, urban wastewater, forestry, domestic wastewater. So these are all significant pressures that are happening in our communities and so on. And different streams have different problems basically. So the bugs that I mentioned earlier being used as bioindicators. That applies to water quality also, and the scientists basically go on out and do a kick sample using a sweep net, where they kick the substrate in the stream, and that loosens the gravel, and all these insects basically swim into the net, and they do a judgment then on the amount of beneficial or pollution tolerant species that are actually in the sample. So you can see there some of the species that are pollution sensitive, that they include the mayfly and the stonefly, for example, and then pollution tolerant species, freshwater, leeches, and so on. And this data is backed up by chemistry sampling and river morphology and so on, hydromorphology. So what are the main significant agricultural pressures? Phosphate, it's the #1 probably up in this part of the country due to the soil type and a lot of the areas and the amount of rainfall and so on. And then we also have nitrate and leaching in our free draining soils. We also have a problem with ammonium and peat. When peat dries out, when it's drained, it actually causes ammonium to be released into the water as well. And then we also have a problem with sediment in terms of bare soil being washed into our streams. Sediment and phosphate actually bind very tightly together, and they go hand in hand when they're being washed off our fields. And then some catchments then as well, we have toxic effects such as MCPA, for example, and sheep dip coming up in the samples. So if I just give you some ways to enhance biodiversity between now and new cap and so on, it's typically more effective basically to retain the existing habitats that's there rather than establish new ones. So that means leave the whitethorn tree in every hedge line. You probably have them already. Allow routinely trimmed hedgerows grow taller. As I said, an untidy hedge isn't a bad thing for biodiversity. Allow those birds and bats nest in your buildings, your outbuildings, and identify and control invasive species such as Himalayan balsam. That's the photo of it on the bottom right hand of the screen, and it thrives in damp soil conditions beside streams and so on. Then plant native hedgerows if you are going to rejuvenate a hedgerow or want to put in new hedgerows and trees, and that's the important thing there, native, as I showed the number of insects that they support, and also protect our waters. So in summary, the glass is going to be rolled over for next year. There's a new pilot scheme coming into the fold next year also. And the topic of tonight's presentations have been focusing on climate change, water and biodiversity. And they are going to form a significant proportion of the next cap. And what the focus will more than likely move on to the quality of habitats. And they may well form results-based schemes into the future. That remains to be seen. So that's it. Thanks very much for your attention, and I wish you a good night, and I'll pass you over to Cian.
Thanks very much, Shaun. I'm aware that we are just tipping 9 o'clock, so we're just on the hour. So there are some questions after coming in, so we'll try and get a few of them answered anyway here. Eamonn, are you on there?
Yes, Cian, I'm here.
Just a question there, Eamonn, about the conversion of slurry to bioenergy. Just if you want to just say something short about that. How do you convert slurry to bioenergy?
Yeah, convert it using an anaerobic digester. That's basically how it's converted. Now it's an expensive piece of kit. As far as I know, there's no grant available, say through TAMS or any other Department of Agriculture scheme for, say, a non-farm type setup. The only grants that seem to be available are more commercial through the SSRH scheme, sustainable scheme for renewable heat, but they're more pitched at commercial operations. So it's an area that there's it's kind of an abeyance at the minute, and there is no support at the minute to get involved in anaerobic digestion just yet. So, but maybe watch that space, and there might be something in the future.
Thanks, Eamonn. Actually, Shaun, you can stop sharing your screen there, and I have a question for you, Shaun. If you can hear me there. Just can you just make a comment? There's a question there on what kind of eco schemes will form part of the next CAP. Do you just want to make a comment there, Shaun, on on what they're likely? Are they likely to be like the schemes in the past, or will they be like the more recent ones, or something different perhaps?
Yeah, well, just they're primarily going to focus on concepts such as precision agriculture, for example. Agroforestry is going to be come into the fold. Organic farming is going to be increased, and there's there's going to be, it's going to revolve around ecological measures, basically. So that remains to be seen. We just don't know how that's going to pan out, but they're the main headings that they're going to fall under.
Okay, thanks very much, Shaun. Just I see a question there has come in asking about the extra requirements which are mandatory and which are voluntary, and when we'll know the additional requirements for the derogation farmers. And I'm going to answer that briefly, in that we have next week's webinar is specifically on the question of derogation farmers, what the situation is with them, and what the new rules coming in 2021. So that will be next week's topic. Just given the time, we're running well over 9 o'clock now, so I'm just going to bring things towards a close. That's it. I hope you found the presentations hopefully useful and interesting. Now, the first 3 webinars in the series will be available on our YouTube channel, so our regional Sligo Leitrim Donegal YouTube channel tomorrow, and this webinar will be available then on Thursday. And all of the links will be circulated through our social media platforms once they're available. Next week, just bear in mind that we are moving to Monday evening next week, just for that week. Next week will be Monday, and then return to the usual Tuesday slot the following week. So next Monday evening at 8 p.m, where the topic will be the nitrates derogation and all of the new rules required for 2021. As I mentioned, each week you can find full details by following Teagasc SLD Sligo Leitrim Donegal on Facebook, Twitter and Instagram. And that's it for this evening. And remember, despite the current restrictions, you can always contact your Teagasc advisor by phone, text and email. That's it for tonight. Thank you for joining us. Stay safe.
Thank you.
Good night.
Good night.